Okay, I got a question today in class that I didn't have the book for, so I thought I would just do a short video. It was about this problem right here, 3a and 3b, on chapter 6.3. Use the common method for implementing the standard division algorithm to calculate 1,875 divided by 8, and then interpret each step in your calculation in part A in terms of the following problem. You have 1,875 toothpicks bundled into 1,800s, 7 tens, 5 individuals. If you divide these toothpicks equally among 8 groups, how many toothpicks will each group get? So how many in each group division type contextualization of the problem. So the question really had to do more with part B, but here's part A here. Part A would just be to enact the standard algorithm. But part B says, well, how does the standard algorithm correspond to this? How many in groups? How many in each group division problem where we have this many toothpicks in these many bundles and we're dividing them into 8 groups and asking the question how many in each group. So if we look here at the beginning, what we did is we said, well, 8 goes into 18 2 times, and I guess when we subtract we get 2 left over. So really, if you kind of think about what's going on here, there's really a 0 here, right? And we're subtracting 1600 from 1800, and 1600 is how many, I guess that's 800 times 2, right? 800 times 2. So I think what we need to think about is, well, if we have 1,000 bundle and an 800 and 100 bundles, when we put those two together, what we end up with is we end up with 10 of those 100 bundles could be thought of here. We have 18 100 bundles is really what's going on. So in this first step, what we're doing in this first step is we're saying that we have 18 100 bundles, and when we deal them into 8 group, each group gets 2 of the 100 bundles. So we're dealing out the 100 bundles, and they go around twice to the groups, so that gives 16, which means that there are 2 100 bundles left over. So that's really what's going on in the first I guess, subtraction and division piece. Let's just take a look at one more of these. So now instead of doing 100 bundles, in the next step, if we sort of think of this as 270 and 240, if we kind of think of it that way, I know that the 7 got brought down here and that the 5 will get brought down here, but remember, we're just concentrating on the place value of interest in this particular case, and it looks like it's the tens. So instead of 100 bundles, now we're looking at 10 bundles. We've got 7 of the 10 bundles, but there's 2 100 bundles left over, right? And each of those 100 bundles has 10. So it looks like we have 27 10 bundles now. So that's what the 27 means. It's 27 10 bundles. And we're dealing them out to 8 groups, and we ask how many does each group get if we share this equally. And each group gets 3, right? And when we give each group 3, that uses up 24 of the 10 bundles, and there's 3 left over. 3 10 bundles left over. So I'll leave this, that's the second step. I'll leave this last piece, the third step, up to you to figure out, but I hope that at least gets you started thinking about how you can kind of think about each one of these steps in the division algorithm as an equal sharing type of division problem, where we're dealing out toothpicks that are arranged this way in bundles. And usually the way it works is we start with the highest bundle and ask how many of those we can deal out, and if you can't do that, then you break it up and make the next set of bundles the first one that basically deals out to the number of groups that you're dividing it into. I hope that gives you some, I guess, at least a toehold on how to start this one. Try to answer the last piece on your own.